Hello and welcome to Geospatial Analysis with Python. So in this session we'll be looking into false color composite generation, and the dataset that we'll be using is the Sentinel dataset. So why wait? Let's get started and jump into our Jupyter notebook. So this is the Jupyter interface that you will be getting. So if you do not know how to install Jupyter or how to install Python, just go to the description link and you will find it out. So we require two particular libraries. So let's see what libraries we'll be using. So this is EE, where EE stands for Earth Engine. So we'll be installing it. I'll just go back to my Jupyter notebook. I have written it, so I'll uncomment it and I'll run it. So in the meantime, I'll go to another library, that is the GEE map. This is called Google Earth Engine map. So we'll just copy it from here and jump back to the Jupyter notebook. So I've written it, I'll uncomment it and I'll run it. So as you can see, for the first library, that is the pip install EE, we have the requirement already satisfied. It means I have already installed it. You might get that the library is installed successfully, you might get this message, and similarly here we are getting the requirement already satisfied. So if you have installed it already, no issues, you can move forward. So next is, after installing the libraries, we need to import it. I'll just uncomment both the imports and I'll run it. So as you can see, we have imported successfully and without any error. That's it, we are good to go. So let's create a map. So I'll make a variable called map and I'll pass it on the function geemap.map, and I'll just write map and I'll play the run button. So you can see a map will be generated over here like this. So this is similar to your Google map. You can drag it, you can zoom it, you can create point, lines and polygons to it. So I'll just zoom it to my target location. So we will be creating the false color composite for Delhi NCR region. So this is our target location. So but there is a problem with this function. Every time I run this line, you can see the map reboots itself and we have to again zoom to our target location. So in order to avoid that, we have to set a map center. So I'll uncomment the function that is the map.setCenter, and I'll pass it on the latitude and longitude of Delhi NCR region, and I'll set the zoom level. So this 8 represent your zoom level. You can increase it, you can decrease it, you can put it 5 and you can put it 10 also. So it's up to you. So you have to end every line with a semicolon. We are good to go. I'll just put a run button and you can see this time the map is already shifted rather than focused into our target location. That's it. Now we have to create a location point. So I'll create a variable and I'll pass it on the function ee.geometryPoint, and I'll pass the same latitude and longitude. You can pass it on some different latitude, but this particular line of code will help us to clip our data. So I'll just pass the same latitude and I'll just put a semicolon to it. I'll run it and we have successfully set our location point. Now we have to take the data. So let's uncomment it and see where we can get our data from. So I'll just go to my browser and type here Google Earth Engine datasets. So just enter it and you will getting this link, that Earth Engine data catalog. Just click it and you will be landing on a page called Earth Engine data catalog. So this contains a huge collection of data. So we are interested in the Sentinel data. So I'll just click it over here and we'll land on the Sentinel collection page. So I'll scroll it down. So it has huge number of collection as well. So we'll go for the Sentinel-2 multispectral instrument. So I'll click it here. So we are on the Sentinel-2 page. So I'll scroll it down and you can see there is surface reflectance. The availability of dataset is also there. There is top of atmosphere reflectance and dataset availability is present here as well. So we'll go for top of atmosphere reflectance. You can find it out for surface reflectance as well, but we are going for top of atmosphere reflectance. I'll click it and we have landed on the page called Sentinel-2 multispectral instrument. You can see the dataset availability and the dataset provider also here, and the Earth Engine snippet is also mentioned. So I'll just copy the Earth Engine snippet and I have already pasted it over here. You can paste it in front of your data and you are good to go. Now we require a particular function called filter bounds in order to generate the data based upon our point. So we have a location point and we have the data. So in order to clip the data based upon the location point, we are using filter bounds. You just pass on your point function that you have generated over here. You pass it on, you put it a semicolon, and you just play the run button. So we have successfully imported the data into our Jupyter notebook. So let's move forward and clip the image that we require from this huge data collection. So I'll just uncomment it and I'll pass the function ee.image and I'll pass my data into it. This is the variable, so I'll write it here, and I'll apply a function called filter date, and in that I'll pass 2019 1st of January and 2019 31st of December. So this is the time duration that I am taking, a whole complete year. You can vary it, and I'm sorting the data based upon the cloud coverage assessment. So where does this come from? Let's jump back to our data set and scroll it down. You can see we have a description section, we have a band section, we have image properties, and we have terms of use. So we will make use of image properties. As you can see, there is a huge number of information that is given over here. So we are interested in some specific properties such as cloud cover assessment. So I'll just copy it, jump back to my Jupyter notebook, and I'll just paste it over here in the sort section. So from this sorted data, I'll just select the very first image using this first function. So I'll just end this line using a semicolon and I'll play the run button. So we have successfully imported a particular image from this huge data collection. So what we are doing, we are creating a point, then we are restricting our region of data, then finally we are restricting the image that we require in order to display. So the next function is we need to create a display function. So for that I'll just uncomment it like this. Okay, so we are good to go to band the functions, but in order to create a display we need to mention these bands. Now what are these bands? Let's go back to our data set. Let's see, we have a band section. So we have a huge number of bands over here. So we can say we have band 1, band 2, and so on and so forth. So we have a red band, then we have a green band, we have a blue band. So we'll be using it. Let's jump back to our Jupyter notebook. So these are the bands for a true color image, because we can see from our data, band 4 represents the red band, band 3 represents the green band, and band 2 represents the blue band. But we require a false color composite, so we'll be using band 8, that is the NIR, and we'll be using band 4, that is the red band, and finally we'll be using band 3, that is the green band. So let's jump back to the Jupyter notebook and type band 8, then we'll be using band 4, and finally we'll be using band 3. That's it. So I'll put the minimum value as 0 and maximum value as 3000, and I'll just run it. So we have successfully run it. Now let's create the map. For that we'll use a function map.addLayer, and I'll pass my image layer and my display layer to it. I'll put a semicolon to it, and finally I'll call my map and I'll just run it. So as you can see, a nice false color image is generated. So I'll just zoom it so you can see over here. So we have a nice false color composite that we have generated. That's it. Thank you. And you can generate your own image using your own latitude and longitude. So we are good to go now. Thank you and see you next time.